So I started with nothing, an empty space. And then we add Earth, our home. Look at this. Earth is perfectly balanced. Mass, enough to hold air, but not crush life. Gravity keeps us grounded, but lets us move. Temperature, just right for liquid water. Rotation gives us day and night. Everything perfect. But let's look deeper. Earth similarity, 99.8%, almost perfect for life. But life likelihood, 91.8%, not 100%, because Earth isn't perfect. Some places are too hot, too cold, or too dry, and disasters keep disrupting life. So Earth is nearly perfect, just not everywhere. And that balance can break with something coin-sized. So first, I needed a black hole. So I started fresh, nothing, just space. And then I chose the moon to turn it into a black hole. So I started increasing its mass more and more until it reached 9.08 times the mass of Earth. But mass alone isn't enough. To become a black hole, an object must be compressed so much that its gravity doesn't let even light escape. So I reduced its size while locking the mass. Same mass, but in a smaller space, means stronger gravity, much stronger. This creates something called the Schwarzschild radius, the point where escape velocity equals the speed of light. Cross that limit and nothing can escape, not even light. So when its radius dropped below 10 centimeters, it crossed that boundary. And in that moment, it collapsed into a black hole. And there it was. But I didn't stop there. I wanted it coin-sized. So I compressed it down to just 2 centimeters, just smaller, 2 centimeters, holding more than twice the mass of Earth. That's not density, that's gravity, pushed to the limit. But there's a problem. You can't actually see it because it doesn't emit light. So to track it, I changed its color, just so we can see where it is. Because what you're seeing isn't the black hole itself, but space bending around it. And then I saved it, giving it a name, Moon Black Hole, because this used to be the moon. Now we bring Earth back, just like before, calm, stable. And then I placed the black hole right next to it, just 4,000 kilometers away. That's closer than most satellites orbit Earth. And at this distance, gravity starts to take control. And then something strange happened. The water started to move, not randomly, but in one direction, toward the black hole. Oceans rising over continents, flooding entire regions. But that's not the scary part. In just 2 to 3 minutes, everything changed. All the water dragged to one side, forming a massive ocean wall, while the other side started drying out. This is tidal force, gravity pulling harder on one side than the other, stretching the planet from the inside. And this is only after a few minutes. So I pushed time forward, and this is what happened. Earth is no longer stable. Oceans displaced, surface stretched, gravity taking over. But this isn't the worst part. Just a few minutes later, Earth loses its shape, stretching into something like an egg. One side pulled harder than the other, tidal forces tearing it apart from the inside. And then temperature rises instantly, crossing 100 degrees Celsius. And then it reached its limit. In an instant, Earth broke apart. Not slowly, not gradually, but violently. The entire planet shattered into fragments. Pieces of Earth thrown into space, glowing from extreme heat. This is the result of overwhelming tidal forces and internal stress, exceeding what the planet can hold. What was once a world is now nothing but debris. Earth is gone. And then I had an idea. What if this coin-sized black hole could explode? So I did it. In an instant, everything lit up. It turned into a supernova, specifically a Type 2 supernova. A Type 2 supernova happens when a massive object collapses under its own gravity and then rebounds violently. The core compresses to an extreme state, then releases an enormous amount of energy. That energy blows everything outward, creating this massive explosion. And that's it. Earth gone. All because of something coin-sized. If this showed you how extreme physics can get, then you'll love what's coming next. Subscribe to Curiomos for experiments that push reality to its limits. And tell me in the comments, what should we test next?